Have you ever really thought about what it takes to work in healthcare? It's way more than just caring for people. It's about a deep, fundamental understanding of the science that makes our bodies tick. And today, we're going to dive right into that science by breaking down a real final exam.
Okay, so take a look at this. This isn't just some random test paper. This is a gateway. It's a first-year final exam for nursing students covering biochemistry and biophysics. The answers to these questions? Well, they're the bedrock, the scientific foundation every single nurse has to master before they can even think about caring for you or me.
So, here's a question for you. Could you pass this thing? Let's find out together. We're going to walk through some of the biggest ideas from these exams and really get into what makes the human body work. Sound good? Let's do it.
Here's our game plan. First, we'll take a quick look at the exam itself. Then we'll get into the body's chemical machinery, talk about fuel and fat, see how physics gets used in a hospital, and then we'll finish up with a cool diagnostic test that brings everything together.
What's so cool about this exam is how it's structured. It's basically split into two completely different worlds that together explain everything about us. You've got biochemistry, which is the actual chemistry of life, and then you've got biophysics, which is all about how the laws of physics operate inside us. Two distinct worlds, all happening in one body. So, let's kick things off with biochemistry. You can think of this part as exploring all the tiny, microscopic workers and systems that are running around inside our cells 24/7, building, repairing, and cleaning up. We're talking enzymes and waste management.
And check this out. This shows you just how important some of this stuff is. We've got exam papers from 2 different years, and they're both asking the exact same thing. Describe the factors affecting enzyme action. When you see a question pop up over and over again like that, you know it's a big deal. It's a cornerstone concept.
So what in the world are these enzymes they keep asking about? Honestly, the best way to picture them is as these tiny, super efficient little robots working on an assembly line inside our cells. Each robot has one, and only one, very specific job, and they make chemical reactions happen millions of times faster than they ever could on their own. Absolutely essential.
So back to the exam question. What can mess these little robots up? Well, just like any complex machine, their environment has to be just right. Temperature and pH levels need to be perfect. This is exactly why a dangerously high fever or a shift in your blood's acidity is so serious. It literally causes these critical machines to grind to a halt. And of course, how many robots you have and how much raw material they have to work with also dictates how fast the job gets done.
Now, all this activity, it creates waste. That brings us to the body's cleanup crew. Take a look at this question from a 2015 exam, asking students to draw the urea cycle. Now, this isn't just some abstract chemistry diagram. This is a blueprint for the body's essential, life-saving detoxification system.
The urea cycle is basically our body's own internal treatment plant. When we break down proteins, it creates ammonia, which is super toxic. So the liver grabs that ammonia and runs it through this cycle. A series of enzyme-driven reactions convert it into a much safer compound called urea. Then, the urea can be safely shipped off to the kidneys to be filtered out. If this cycle fails, it's a massive medical emergency.
Okay, so we've got the machinery and we've got the cleanup crew. But what's powering this whole operation? That brings us right to the next big topic from the biochemistry section. Carbohydrates and lipids, the molecules that give us energy and literally build our bodies.
And here it is, another question straight from the 2021 exam. Give an account on classification of carbohydrates. This is as fundamental as it gets. A nurse has to understand this stuff inside and out to help manage everything from nutrition plans to diabetes.
And here's the bottom line, the most important thing to remember. Carbohydrates are the body's #1 go-to fastest source of fuel, period. Whether it's a simple sugar for a quick burst or a complex starch for sustained power, carbs are what keep us thinking, moving, and living.
And right there with carbs, you've got this question about lipids, which, we usually just call fats. And again, the exam wants students to classify them. This isn't about labeling fats as good or bad. It's about understanding the huge variety of jobs they have in the body.
And trust me, those jobs are critical. Lipids are our backup, long-term energy supply. They form the membrane, the protective wall around every single cell in our body. They insulate us, they help us absorb key vitamins, and they're even the building blocks for essential hormones like estrogen and testosterone. See, so much more than just energy storage.
All right, let's totally switch gears now. We're moving on to the second part of the exam, biophysics.
This is where we see the fundamental laws of the universe, forces, waves, energy, get put to work in a hospital to figure out what's wrong and how to fix it.
So a classic biophysics topic is medical imaging, right? Questions about ultrasounds and x-rays are all over these exams. And the key is knowing which tool to grab for which job, and that all comes down to the physics. Ultrasounds use sound waves to see soft tissues in real time. Think of watching a baby in the womb. X-rays, on the other hand, use radiation to get a static picture of dense things like a broken bone. Different physics, different jobs.
Now, here's a question about pure, raw mechanics. What is traction? This might sound a little old school, but the physics behind it are absolutely timeless and are still used today to help people recover from really serious injuries. At its core, traction is just applying a pulling force. That's it. But in medicine, that force is calculated with incredible precision, using physics to gently pull bones back into alignment after a bad break, or maybe to take pressure off the spine. It's literally a direct application of Newton's laws of motion to make a person better.
Heat and temperature are concepts that you see everywhere in these exams, and this really shows you why. We use it for both treatment and diagnosis. You've got things like diathermy, which uses energy to heat deep tissues to help them heal. Then there are wax baths for more surface-level heat therapy. And of course, there's the humble thermometer, a super basic tool that works on the simple physical principle of thermal expansion.
So we've looked at biochemistry and biophysics like they're two separate things. But the real magic, the coolest stuff, happens right where they overlap. Let's look at a tool that perfectly brings these two worlds together, the electrocardiogram, or ECG.
And I just love this. This is an actual student's hand-drawn diagram of an ECG waveform from their exam. This little sketch is the perfect symbol of that leap from just knowing the theory in a book to being able to actually apply it and see it in the real world.
So what is an ECG actually measuring? This is the beautiful part where all clicks. Those squiggly lines on the monitor, that's the physics. It's a machine measuring electricity. But where does that electricity come from? That's the biochemistry. It's being generated by tiny chemical ions surging back and forth across the membranes of heart cells with every single beat. The ECG is a physical printout of a completely chemical event. It's where these two worlds become one.
When you really look at these exam questions, it opens up this whole hidden world. The human body is an absolute masterpiece of applied chemistry and physics. It really makes you appreciate the incredible level of knowledge that healthcare professionals walk around with every day. And it just leaves me with one final question for you. What other everyday technologies do you think rely on this same hidden science?